So, I have some Legos here. I'm going to find a tower to be a collection of Lego pieces stuck together. So this is a tower with 2 pieces, this is a tower with 3 pieces, and this, just the piece itself, is a tower with 1 piece. It is just the piece itself. I'm also going to find a move as sticking 2 towers together to create a larger tower. So this is a tower with 1 piece, this is a tower with 1 piece. We do 1 move, and now it's a tower with 2 pieces. Okay, so how many moves does it take to create this tower with 1 piece? Well, it's 0 because it already exists just by the Lego existing. It is a tower. How about 2 pieces? If I want to make a 2-piece tower, how many moves does it take? Well, it's pretty clear. It just takes 1 move to join 2 1-piece towers to create a 2-piece tower. How about with 3 pieces? Well, I can attach green to red here, so that's 1 move, and then maybe attach this 2-piece tower to yellow, so that's 2 moves, right? That's 2 moves to create it. Now there's multiple ways I can create it too. What if instead of green onto red, I put yellow onto red first? So 1 move there, and maybe I put this 2-piece tower onto green. That's 2 moves. Okay. Now I could also put yellow onto green, so let's do that now. That's 1 move, and I could attach these 2 towers here. That's 2 moves right there to create a 3-piece tower. So we just saw no matter how I created this tower, it took 2 moves to create this 3-piece tower. And so you might ask yourself, let's say 6 pieces here, how many moves does it take to create a 6-piece tower? Well, we saw with 1 piece, it took 0 moves. With a 2-piece tower, it took 1 move. And with a 3-piece tower, it took 2 moves, regardless of how I created the tower. And so with the 6-piece tower, it seems natural that it takes 5 moves to create this tower. Okay. But the question is does order matter? Does it matter how I assemble it? And if so, is there a quicker way to assemble a 6-piece tower in less than 5 moves? And surprisingly, the answer is no. No, it does not. There is no quicker way. If I have n pieces creating a tower, it's going to take n-1 moves to create that tower, no matter which order I stack things and how exactly I do it. So I can put orange onto yellow here, that's 1 move. Put light gray onto this green, that's 2 moves. And I could attach red onto this dark gray, that's 3 moves. And I can stack these towers, 4 moves, and 5 moves. Right, so it doesn't matter which order I do it. If I had 1,000,000 pieces, there's going to be so many different ways to combine them, but it's still going to take n-1 moves to create an n-piece tower, which we will see in this video with the method called strong induction. The hypothesis we wish to prove is to make a tower with n blocks. It takes exactly n-1 moves, and we saw that was true with towers with 1, 2, and 3 blocks. Key thing to realize, to create a tower with n blocks, we need to combine 2 smaller towers together, and if we call those 2 towers Tower 1 and Tower 2, and say they have a and b number of pieces respectively, we need a plus b to equal n, the total number of blocks between them, and a and b to be less than n, since you can only have a tower with 1 or more pieces. Now the heart of this proof is we need to assume the hypothesis is true for all towers less than n. So because a and b are both less than n, to make tower 1, it took a-1 moves. To create tower 2, it took b-1 moves by our assumption. So the total number of moves to create towers 1 and 2 is simply a-1 plus b-1. Now when we combine those 2 towers together, that is itself a move. So we just add 1. So that's a-1 plus b-1 plus 1, which is equal to a plus b-1. Now, what is a plus b? Well, a plus b is the total number of blocks between those 2 towers, tower 1 and 2, which is simply just n, as we've seen up here. Okay, so to create an n block tower, it takes n-1 moves, again, if our initial assumption is correct. Now, if we go up here, because we showed it was true for towers with 1, 2, and 3 blocks, our hypothesis is true for all towers less than 4. Therefore, our hypothesis is true for 4. Okay. And so we can do the same thing with 5. Our hypothesis is true for all towers less than 5. Therefore, our hypothesis is true for 5. We can keep going, and we'll see that our hypothesis is true for all numbers greater than 1. Okay, this method we use is known as strong induction. In strong induction, we assume multiple things. So in this case, we are assuming the hypothesis is true for all towers less than n, multiple things. Typically, we know weak induction, which is typically what we first learn, and that one we learn one thing, or we assume one thing and try to jump to the next. However, in strong induction, we assume multiple things and try to iterate along. And so we show this Lego hypothesis is true using the method of strong induction.